Good morning, good afternoon, good evening to everyone who's watching this video. This video is about let's go sidecarless with Ambient Mesh. This is for 90 days of DevOps, and we're going to talk about how Ambient Mesh is, the new architecture in Istio's service mesh. Yeah. So hi everyone, I'm Leon Noon. I work as a customer success engineer at Store.io. These are my socials, my Twitter account and the email account and LinkedIn. If you'd like to connect with me or reach out to me or just have a chat with me. Let's begin. So, Microservices are a pretty good architecture, right? It's been there for many years and people have been using it at scale and all. The one thing that microservices, have is they're quite distributed, right? Distributed applications have a lot of different challenges that come. For example, like how do I observe interaction among services? How do I do secure service to service communication, timeout, communication failures, traffic shaping, and all these things. So with this, there was a concept of service mesh that was introduced, where they would have a programmable framework that allows you to observe, secure, and connect microservices. What this meant is basically you would have a framework that is a standard way of communicating with applications in the mesh. So one example of this was a sidecar property, where you have like a sidecar for each container pod that runs in your cluster or in your on your VM, and you would use that to connect this. So what are the common service mesh functions that present? So few of them are like load balancing, like service discovery, and there's secure service to service communication, traffic controlling, like how do I, if I want to change my route, reroute traffic. So that's also a common service mesh function, policy-based, intention-based access control, traffic metric correction, and an API programmable interface. So all these together make up a service mesh. Right? Most of these functions depends on which service mesh you're using, how they sort of take a different approach to things and all these things. The one that we're talking about today in this presentation is Istio service mesh. So how does a service mesh work? So in general, the service mesh had a control plane that would be HTOD, there would be a sidecar proxy. And if you notice in the diagram, the application does not talk to the other application directly. So using IP tables, the rules were sort of the traffic was routed just to the proxy, and all the traffic from the proxy was routed to the app. Outgoing proxy traffic is different, incoming and like just talking between the applications was only limited to the application and the proxy, nothing more, nothing less. And each proxy used to use something called as MTLS, that is mutual TLS sort of, to connect to each other and connect securely over the network. So what about the Istio architecture? The Istio architecture is also similar. It uses the sidecar proxy. There's service A, there's service B, there's a sidecar proxy attached to each container that runs in your pod. So for each pod, you'd have one sidecar, and that would be the data pool. That is where all your configuration and everything is managed. And the sidecar used to be an Envoy sidecar. Envoy proxy is like a CNCF graduated project built by Lyft, right? And it's a very fast and performant proxy. So they use that as a sidecar. And what HTOD is basically is like a control plane. So you tell HTOD, okay, I want a virtual server or something like that, and then it would translate the configuration into Envoy configuration and push these to the sidecar proxy. Right? There's also a thing of traffic inside the mesh, outside the mesh. So this is called as ingress and egress. Right? So there is incoming traffic that is secure, and there's also outgoing traffic that is secure to other services. Also, HTO recently graduated as a CNCF project, so now it is completely under the CNCF, and all the people are working towards like making it much better and sort of improving it day by day. So all this came out something called as ambient mesh. Since the sidecar proxy is good, but it had a bit of complexity to it in terms of things like certificate rotation, things like cost reduction. Like each container had a different sidecar. So each container needed a sidecar. If you had 100 pods in the cluster, you would have like 2x amount of resources used by the sidecars and all these things. There were also some performance challenges that we won't be discussing, but there were some challenges. So this new ambient mesh is like an open source project in the Istio project, and it also has a sidecarless data plane. So there is no sidecars anymore. And the major contributors to this are Io and Google. So what exactly is the Istio ambient mesh? The Istio ambient mesh is sort of a architecture where you have one proxy per node rather than having one proxy per container. And with this, there were a lot of improvements. So if you're a business owner, you would have reduced cost. Like you could have more business continuity and flexibility. If you're a platform team, you had things like simplified operations, reduced maintenance, simplified update, easier to add applications and all these things. And as an application team, the mesh is sort of transparent to the app. And the applications won't break because now you don't have, each app talking to a proxy. It's more like each app talking to just one proxy, right? Rather than having each proxy per pod. Istio, the most useful, like I've seen many people use Istio just for this, is because it provides zero trust security out of the box, using MTLS and identity management using Spiffy. So the zero trust security also has changed on it because in the sidecar pattern you had all the traffic going through the proxy. The proxy handled both. You should do MTLS and it also used to do the L7 application layer stuff. But in the ambient mesh, what is there is the alpha proxy is a separate proxy called ztunnel, and the L7 proxy is a separate proxy called waypoint proxy. And the way it works is the alpha proxy manages all layer 4 and layer 3 stuff, and the L7 proxy manages the layer 7 related feature. So we can also see this here. So ztunnel node is sort of responsible for securely connecting and authenticating workloads within ambient mesh. Right? And it only does L3 and L4, the ztunnel. And for L4, there is waypoint proxies. And the way these communicate over a network is using something called as an HTTP connect based traffic that is most popular in proxies, and it's called Xbone. That's the tunneling protocol. So yeah, so using this we get a lot of flexibility with cost, operational flexibility and performance, since now you have just one proxy per node rather than having each application sort of have a proxy. So let's dive into the architecture a bit, right? The way this works is you have the app A running maybe in one node, and app B in another node, app D in another node, right? You have your CNI layer and you have ZTUN that runs on each node. So you will have an identity for this that will be sort of impersonated. Like you will have to trust the ZTunnel will trust this, and it will sort of create a spiffy ID, and it will also do, okay, if it's a MTLS in the between connects to app D, that is the waypoint proxy, and there is MTLS here to the Z tunnel and the CNI layer normal, and then there is the app D, right? So that's how it sort of connects over a secure layer rather than having the unencrypted traffic. This is a tunnel where you have only like L3 and L4 capabilities required. So you would not have to deploy a waypoint properly or something. And this is the protocol that is used to connect nodes called HBone, HTTP based overlay network encapsulation. We won't be going into this much, but this is how it looks. There you have the Z tunnel that runs on each node. It connects to the Z tunnel on the other node and sort of reaches out to the services. And this tunneling protocol is called HBone. This is how it looks in like a TCP packet. So yeah, that's it for the presentation. Thank you. You can reach out to me on my socials, or if you have any questions, you can reach out to me on Twitter or something like that. Thank you. Have a nice day. Thank you to Michael for giving me this opportunity to speak at Monday Day Job.